Hi friends, I am Balaji Rao. Welcome to BR Max class. Till now what we learned in this chapter? We learned about Cartesian product of sets and we did the problems related to Cartesian product of sets. In this class we will learn the definition of a relation and examples to understand relation and two important points, and we will learn what is empty relation, what is universal relation in this class. First, you take A comma B are any two non-empty sets. You take A comma B are two non-empty sets. Then any subset, this is important, then any subset of A cross B, this is the main line. Any subset of A cross B is called a relation from A to B. You can understand this very easily with an example. I'll consider two sets A comma B like this. Set A is 1 comma 2 and set B is 3 comma 4. What is relation? Any subset of A cross B. So to understand that, first I'll calculate A cross B. A cross B. We know that how to calculate A cross B. You take the element 1 and you pair with all the elements of second set. The order pair 1 comma 3, the ordered pair 1 comma 4. Now you take the second element and you pair with all the elements of second set. Then what you will get? Ordered pair 2 comma 3, ordered pair 2 comma 4. Okay. So this is A cross B. Now what we need to understand? We need to understand that any subset of A cross B is called relation from A to B. I'll do one thing. I'll write a subset of A cross B. I'm naming it as R. You see here, I'm taking R like this. You observe in this set how many elements are there? Only one element is there. What is that element? Ordered pair 2 comma 3. Correct? Now the ordered pair 2 comma 3 is present in A cross B. Yes, ordered pair 2 comma 3 is present in A cross B. What it tells? It tells that R is a subset of A cross B. All the elements present in R are present in A cross B. That's why R is a subset of A cross B. What is the definition of relation? Any subset of A cross B is called a relation from A to B. Here R is a subset of A cross B. So R is called a relation from A to B. Why we are saying that R is a relation from A to B? Because R is a subset of A cross B. What is the definition of relation? Any subset of A cross B is called a relation from A to B. I hope you understand. Like that, I can write one more relation from A to B. I'll name it as R1. Okay. And I'll write another relation. You observe this R2. How many elements are there in set R2? Two elements are there. One is ordered pair 1 comma 3. Another is ordered pair 2 comma 4. All the elements present in R2 are present in A cross B. You observe here order pair 1 comma 3 is there. Order pair 1 comma 3 is there in A cross B? Yes, it is there. You take order pair 2 comma 4. Order pair 2 comma 4 is there in A cross B? Yes, it is there. That means all the elements present in R2 are present in A cross B. What it tells? It tells that R2 is a subset of A cross B. When R2 is a subset of A cross B, then what we can say? We can say that R2 is a relation from A to B. Similarly, I'll consider one more set R3 like this. The ordered pair 1 comma 4, the ordered pair 2 comma 5. You observe, it is a subset of A cross B. When we say R3 is a subset of A cross B, all the elements present in R3 are present in A cross B, then we say that it is a subset. Then we say that R3 is a relation from A to B. You observe here order pair 1 comma 4. It is present in A cross B. Yes, it is present. Ordered pair 2 comma 5 is present in A cross B? No, it is not present in A cross B. Is R3 is a relation from A to B? No, R3 is not a relation from A to B because this ordered pair is not in A cross B. I hope you are understanding. What is definition of relation? Any subset of A cross B is called relation from A to B. Here you see, I'll consider R3 like this. Order pair 1 comma 4. Ordered pair 2 comma 3, ordered pair 2 comma 4. You observe, it is a subset of A cross B. Here order pair 1 comma 4 is there. It is there in A cross B. Ordered pair 2 comma 3. It is there in A cross B. Ordered pair 2 comma 4. It is there in A cross B. All the elements present in R3 are present in A cross B. That means R3 is a subset of A cross B. When R3 is a subset of A cross B, then what you can say? You can say that it is a relation from A to B. Now, we will learn a few particular cases here. R4. You observe, I considered an empty set. Is empty set is a subset of A cross B? Yes, we know that empty set is subset of every set. Is empty set is a subset of A cross B? Yes, empty set is a subset of A cross B. If empty set is a subset of A cross B, is empty set is a relation from A to B? Yes, of course. Because as per the definition, any subset of A cross B is called relation from A to B. Okay, so here it is a subset of A cross B, so it is a relation from A to B. This is the special case. This relation is known as empty relation or void relation. I hope you are understanding. Okay, now another particular case is there. I'll consider a set R5 like this. If you observe this, I just considered A cross B only. What is R5? R5 is nothing but A cross B. You observe that is R5 is a subset of A cross B? Yes, of course. We know that from sets chapter, every set is subset to itself. Is R5 a subset of A cross B? Yes, it is a subset of A cross B. When it is a subset of A cross B, then we can say that it is a relation from A to B. Yes. So here R5 is a relation from A to B. Moreover, this relation is called universal relation. This relation is called a universal relation from A to B. Till now, what we learn in this class, we learn the definition of relation and we try to understand what is this relation with examples, and we learn another two definitions, and one is a void relation, another one is universal relation. Now, very important points related to this relation. You observe here for A cross B, how many relations we are writing? Here I written 5 relations. Like that, you can write some other relations also. But the point is, how many relations we can write from set A to B? How many relations we can write from set A to B? Here, how many subsets are possible for A cross B? That many relations we can write. Please try to understand. How many subsets you can write for A cross B? That many relations are possible. In the chapter sets, if set A has m elements, for example, I'll write here. If set A has m elements, then number of subsets of A. How many subsets we can write for set A? We can write 2 power m subsets that we learn in sets chapter. Here the set A cross B is having how many elements? Here how many elements are there? Total 4 elements are there. So how many subsets you can write for A cross B? You can write 2 power 4 subsets for A cross B. 2 power 4 is nothing but 16. So for this example, how many relations you can write like this? You can write 16 relations. So note point. You observe this point. Set A has m elements. In set A, m elements are there. Set B has n elements. Then number of relations from A to B. As we discussed in the last example, how many relations we can write from set A to B? 2 power. How many elements are there in A cross B? That many relations we can write. Okay. So if set A has m elements, set B has n elements, then number of relations from A to B equal to 2 power number of elements in A cross B. Or in other words, you can write like this. In Cartesian product of sets, we learn this point. If set A has m elements, set B has n elements, how many elements will be there in A cross B? A cross B contains mn elements. That means product mn. So if set A has m elements, set B has n elements, then number of relations from A to B equal to 2 power n of A cross B, or you can write 2 power m into n. Okay. Note 2. This is very important point we use very frequently throughout this chapter. If R is a relation on A, we see this terminology very frequently while solving exercise problems. R is a relation on A. R is a relation on A. What it means? R is a relation on A means it is a relation from where to where? It means that R is a relation from A to A. From now onwards, you remember this. Whenever you see R is a relation on set A, it means that R is a relation from A to A. In case while solving the problems, if they given that R is a relation on set of natural numbers, it means that R is a relation from natural numbers to natural numbers. I hope you understand the definition of a relation. In this class, we will learn the definitions of domain, codomain, and range of a relation. You consider R is a relation from A to B. When R is a relation from A to B, then which one is called domain of the relation? You see, what is domain of the relation? The set of all first elements of ordered pairs. The set of all first elements of ordered pairs in relation R is called domain of the relation. We'll understand this more clearly with an example. But first let me complete all the definition. What is codomain of the relation? R is a relation from A to B. Then the set B, the whole set, the full set B is called codomain of the relation. However, we can understand this very clearly with an example. First let me complete all the definitions. What is the next one? Range of a relation. What is range of a relation? The set of all second elements of ordered pairs in relation R is called range of a relation. Now we'll get more clarity about this domain, codomain, range with an example. In this example, I am considering set A as 1, 2 and set B as 3, 4, 5. Okay. From this, what is A cross B? I'll write A cross. Now, I'll consider a relation from A to B. You observe here, I consider a relation R from A to B. What is the definition of relation that we learned in last class? All the elements present in R are present in A cross B. You see, order pair 1, 4 is in A cross B. Order pair 1, 5 is in A cross B. Order pair 2, 5 is in A cross B. Here, R is a subset of A cross B. We know that if R is a subset of A cross B, then R is called relation from A to B. So here, it is a relation from A to B. Is a relation. It is a relation from where to where? It is a relation from A to B. Now the point is, what is the domain of this relation? What is domain of this relation? As per the definition, what is domain? The set of all first elements of order pairs. In the relation, you observe, in this relation, set of all first elements. Please observe here. 1 is the first element and 2 is the first element. 1 is the first element and 2 is the first element. The set of all first elements of ordered pairs in a relation R is called domain of the relation. So, what is domain of the relation here? Domain of the relation is 1. Again 1 is there, no need to write it again. 1, 2. What is this? This is domain of the relation. Okay. Now, codomain. What is codomain of the relation? You see here, if R is a relation from A to B, set B is called codomain of the relation. Here, R is a relation from A to B, set B is called codomain. So, what is the codomain of this relation? That is set B. What is set B? Set B is 3, 4, 5. This is codomain of this relation R. Now, if we calculate range of relation R. As per the definition, what is the range of relation? The set of all second elements of ordered pairs in the relation R. Set of all second elements of ordered pairs. Okay. So here you see second elements 4, 5, 5. What are the second elements we have? 4, 5, 5 again it is there, but we already written 5. So we calculated domain, codomain and range of this relation. Okay. Now we will try to understand this with one more example. Now you observe here, I consider a relation R1. You observe order pair 1, 3 is there in A cross B? Yes. Order pair 1, 4 is there in A cross B? Yes. Order pair 1, 5 is there in A cross B? Yes. All the elements present in R1 are present in A cross B. So R1 is a relation or not? Yes. R1 is a relation. It is a relation from where to where? It is a relation from A to B. R1 is a relation from A to B. Okay. Now I want to calculate domain, codomain and range of this relation R1. What is domain of this relation R1? What is the definition of domain? The set of all first elements of order pairs. You observe what are the first elements of order pairs? 1, 1 is there. So here what is the first element of all order pairs? First elements of all order pairs is 1. So domain of this R1 is 1. Now I'll write codomain. What is codomain? You observe here, if R is a relation from A to B, then set B is called codomain of the relation. Here R1 is a relation from A to B, then what is codomain? Codomain is set B. What is set B in this example? Set B is 3, 4, 5. So codomain of this relation R1 is B. Now I'll write range of R1. As per the definition of range, what is range? The set of all second elements of order pairs. The set of all second elements of order pairs in the relation is called range of the relation. You observe here in R1, what are second elements of order pairs? 1, 3, 4, 5. So what is its range? Its range is 3, 4, 5. Luckily, in this problem, codomain and range of this relation is same, but it is not necessary for every problem. For this relation, codomain is same as range. This is exercise number 2.2, first problem. You observe this question, what is the given information? They given that set A equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. First I'll write the given information, okay? And further, if you observe, R is a relation from where to where, I'll write that information also. They given that R is a relation from where to where? R is a relation from A to A, okay? And how the relation is defined, that is also given in the question. How the relation is defined? Set of all order pairs x comma y such that 3x minus y equal to 0, where x belongs to set A and y is also belongs to set A. This is the given information. What we need to find? We need to find domain, codomain and range of this relation. We know what is domain. What is domain? Set of all first elements of ordered pairs in the relation. If you observe this relation is in set builder form. If this relation is in roster form, then we can write its domain very easily. So what I'll do, I'll try to write this relation into roster form so that we can easily identify what is its domain, codomain and range. So in this exercise, you try to write these 3 steps from the given information. Okay. Now we need to write this into roster form. In this main thing is this one, 3x minus y equal to 0. 3x minus y equal to 0. From this, what is y? What is y? Y equal to, you take y to this side, what you will get? You will get y equal to 3x. Here, important point is x must present in set A, y is also present in set A. Remember that. This x is in set A, this y is also in set A. I need to find order pairs which satisfies this equation. So I'll start x values in set A. So what I'll do, I'll take x equal to 1. You observe here, 1 is there in set A. I taken 1 and I am substituting in this. Y equal to 3 into 1. That is what? 3. Okay. So you observe here, y value we got 3. You observe 3 is there in set A. Yes, 3 is there in set A. Now you take x equal to 2. X equal to 2. You take x equal to 2 and substitute in this. What you will get? Y equal to 3 into 2. 3 into 2 is 6. You observe this y value we got and they given that y must present in A. This 6 is in their set A. Yes, it is there. 5, 6, 7, 8. 6 is there here. Okay. Now I'll take x equal to 3. When you take x equal to 3, what y value you will get? It is 3 into 3. 3 into 3 is 9. Y value we got 9. You check that 9 is there in set A. Yes, 9 is present in set A. Similarly, you take x equal to 4. What is the y value you will get? 3 into 4. 3 into 4 is 12. You check, we got y value 12. You check this 12 is there in set A or not, because y value must present in set A. Okay. Now, if I take x equal to 5, what is y value? Y value is 3 into 5. That is 15. Y value is 15. You check that 15 is there in set A. No, 15 not there in set A. So you cannot take x equal to 5, because when we take x equal to 5, you are getting y value 15. 15 is not in set A. Similarly, when you take x equal to 6, you can take x equal to 6 because 6 is there in set A. When you take x equal to 6, y value is what? Y value is 3 into 6, that is 18. 18 is not in set A. Like that, for rest of all x values in set A, y values are not in set A. So now we can write this relation in roster form. See, I am writing the relation in roster form. Okay. What I got? I got the order pair 1, 3. You can check Here both elements are there in set A, and when you substitute 1, 3 in this equation, it will satisfy. For example, you substitute 3 into 1 minus 3. What you will get? 0 na? It is satisfying. So what is the second order pair we got? We got that order pair 2, 6. You can observe that both the elements are there in set A. When you substitute this order pair 2, 6 in this, it will satisfy. Okay. Next ordered pair 3, 9. Next ordered pair 4, 12. Okay. So they given the relation in set builder form. I written the same relation in what form? Roster form. Why I written into roster form? When it is in roster form, writing domain, codomain, range is very easy. So I'll write the domain of this relation. Domain of the relation R. What is domain definition? The set of all first elements of ordered pairs. You see, in this order pair, all first elements, the set of all first elements of ordered pairs in the relation is called domain. So what are the first elements here? 1, 2, 3, 4. So this is the domain of the relation. Next, codomain. Codomain of the relation. Codomain of the relation. From the definition of codomain, we know that here you observe R is a relation from A to A. So it is a relation from A to A. Na? If it is a relation from A to B, codomain is set B. Here it is a relation from A to A. That means its codomain is set A. What is its codomain? Codomain is set A. What is set A? That is 1, 2, 3 like that up to 14. This is codomain of the given relation. Next, what they are asking? Range. Range of the relation. What is the definition of range of relation? The set of all second elements of ordered pairs in the relation. The set of all second elements of ordered pairs in the relation. You observe what are the second elements of order pairs in this relation? 3, 6, 9, 12. These are the second elements of ordered pairs in this relation. So what is the range of this relation? Range of this relation is 3, 6, 9, 12. So what they are asking? Find domain, codomain, range. We found it. Second problem in exercise number 2.2. You try to understand what is the given information. They given that R is a relation on set of natural numbers. First, you know what are natural numbers. What are the natural numbers? We know that 1, 2, 3, 4 like that. All these counting numbers are natural numbers. It's an infinite set. And R is a relation from where to where? You observe here R is a relation on N. In the theory part, we learn that R is a relation on N means R is a relation from N to N. So that information also I'll write. They given that R is a relation from N to N. You try to understand R is a relation on set N. It means that R is a relation from N to N. Now I'll write what is the given relation. This is the given relation. This relation is in set builder form. This relation is in set builder form. What they are asking? They are asking by using roster form, write down the domain and range of this relation. What I'll do, first I'll write this relation into roster form so that we can easily identify what is its domain and range. To write this into roster form, here they given this is the main information. What is the main information? Y equal to x plus 5. And you observe this is most important. What is that? X is a natural number less than 4. That means what x values you can take? You can take a natural number which is less than 4. So I can take x equal to 1. I can take x equal to 2. I can take x equal to 3. Can I take x equal to 4? 4 is not less than 4. So you cannot take x equal to 4. Now I'll substitute these values in this. Here you see y equal to, when I write x equal to 1 in this, in place of x you write 1. 1 plus 5, that is 6. So y value you got 6. You need to observe here both x and y must be natural numbers. 6 is a natural number, we know that, good. So in place of x I'll write 2 in this equation. What y value I'll get? It is 2 plus 5. 2 plus 5 is 7. You can check that 7 is a natural number. Yes. Now in place of x I'll write 3 in this. So we'll see what y value we'll get. 3 plus 5. 3 plus 5 equal to 8. So for respect to x values, these are the y values. Now I can write this relation in roster form. So what is the order pairs we got from this? We got that the order pair 1, 6. Here you need to observe 1 and 6 both are natural number and x value is a natural number which is less than 4, and this 1, 6 satisfies this equation. What is the second order pair we got? Second order pair is 2, 7. What is the third order pair we got? It is 3, 8. So we got the relation, we written the relation in roster form. Now it is very easy to write its domain and range. Okay, domain of this relation. What is domain of the relation? We know that set of all first elements of order pairs. The set of all first elements of order pairs is known as domain of the relation. Here, what are the first elements? 1, 2, 3, right? So this is domain of this relation. Next, what they are asking? Range. Range is defined as set of all second elements of ordered pairs in the relation. What are the second elements here? 6, 7, 8. So this is the range of the relation. However, in this problem they are not asking what is codomain. In case if they ask, you can write what is its codomain. What is its codomain? R is a relation on n they given. R is a relation on n means it is a relation from n to n. See here, what is if R is a relation from A to B, B is called codomain. Here R is a relation from n to n. What is codomain here? Codomain is set of all natural numbers. This is third problem on exercise 2.2 in relations and functions of class 11. First, you observe what is the given information. They given set A, set B. I'll write the same thing here. I written set A and set B. As they given sets A and B, I'll calculate A cross B, which will be useful while solving this problem. In previous exercise, we learned how to calculate A cross B. Okay, you can check total 12 elements are there in A cross B. Actually, no need to write A cross B, but if you write A cross B, it will be very easy to understand the solution of this question. See, they given set A, set B. I consider set A, set B, and I calculated A cross B. And they are saying that R is a relation from A to B. They given that R is a relation from A to B. And how the relation is defined? They defined the relation like this. See, this is the relation they given in the question. It is an order pair x, y such that the difference between x and y is odd, and they are saying that x is in set A and y is in set B. This information given in the question. Except this A cross B, whatever I written here, all the information is there in the question. You need to write this relation in roster form. Try to understand. They given set A, set B, and they are saying R is a relation from A to B, and the relation is defined like this. In the question they are asking, write R in roster form. Now I want to write this R in roster form. Okay. You can observe here x is there in A, y is there in B. That means x is there in A and y is there in B. You can observe all the elements of A cross B. First elements are there in set A, second elements are there in set B. That we know from the definition of Cartesian product of sets. Here, you identify the ordered pair x, y whose difference is odd. For example, you take the ordered pair 1, 4. What is the difference between 1, 4? To avoid the confusion, you take the bigger number and subtract with smaller number. 4 minus 1. 4 minus 1 is what? 4 minus 1 is 3. 3 is odd number or not? So difference between x and y is odd. So the ordered pair 1, 4 comes to this relation. Why the order pair 1, 4 comes to this relation? Because first element 1 is there in set A, 4 is there in set B, and the difference between 1 and 4 is odd number. Okay. Now like that you take the second ordered pair 1, 6. 1 is there in set A, 6 is there in set B. What is the difference between 1 and 6? To avoid the confusion, you take bigger number, subtract with smaller number. 6 minus 1. 6 minus 1 is 5. 5 is odd number now? Yes, that's why the order pair 1, 6 will come here. Now you take order pair 1, 9. 9 minus 1. 9 minus 1 is 8. 8 is even number. It is not odd. So you cannot take order pair 1, 9 in this relation. Even though 1 is there in A, 9 is there in B, the difference between 1 and 9 is not odd in this case. Okay. Now you take order pair 2, 4. Order pair 2, 4. 4 minus 2 is 2. 2 is even number. That means the difference is even, not odd. So you cannot take order pair 2, 4. You take 2, 6. 6 minus 2 is 4. That means their difference is even. But we want the difference is odd. So you cannot take order pair 2, 6. You see the order pair 2, 9. 9 minus 2 is 7. That means the difference between them is odd. So such order pair only will come here. You try to understand. 2 is there in set A, 9 is there in set B. When we observe the difference, 9 minus 2 is 7. 7 is odd. Only such type of order pairs only will come to this relation. Okay. Now you take 3, 4. 4 minus 3, 1. 1 is odd, na? So it comes here. Order pair 3, 4. Now order pair 3, 6. 6 minus 3 is 3. 3 is odd. So difference between them is odd. So that's why order pair 3, 6 will come here. Now order pair 3, 9. 9 minus 3. 9 minus 3 is 6. 6 is even number. That means difference is not odd. So you cannot take this. Now you take order pair 5, 4. Bigger number minus smaller number. 5 minus 4 is 1. 1 is odd number. No? So this order pair 5, 4 will come in this relation. You can check 5 is there in set A, 4 is there in set B as per this information, and difference between them is odd. Okay. Now what about 5, 6? 6 minus 5 is 1. That is odd. So that means order pair 5, 6 present in this relation. Now the order pair 5, 9. 9 minus 5 is what? 9 minus 5 is 4. 4 is even number. Their difference is not odd. That's it. So I checked all the elements of A cross B. In that, the difference of which ordered pair is odd, those numbers only I written in the relation. So they asked to write the relation in roster form. I written the given relation in roster form. I hope you understand this class. This is fourth problem in exercise 2.2 of relations and functions chapter of class 11. You try to understand what they are asking in this question. The figure shows a relationship between sets P and Q. You observe in the question they given this figure. The diagram is given. This is arrow diagram. You observe 5 is related to 3, 6 is related to 4, 7 is related to 5. What they are asking, write this relation into set builder form, roster form, write its domain and range. First, we need to write this relation in set builder form. Okay, I'll start writing this relation in set builder form. In set builder form, you know that relation contains set of all order pairs. This is set of all order pairs x, y such that. Now you need to write the relation between x and y. You observe here, these are all x values, these are all y values. All these are y values. You please observe carefully. If you observe from this, if we remove 2, we will get 3. From this, if we remove 2, we will get 4. From this, if we remove 2, we are getting 5. You observe what all these are? All these are x values. You observe from this x, if I remove 2, then I am getting y values. Suppose in place of x, if you write 5, 5 minus 2 is 3. In place of x, if I write 6, 6 minus 2 is 4. In place of x, if I write 7, 7 minus 2 is 5. So we identified that here, if we remove 2 from this, you are getting this y value. From this number, if we remove 2, you are getting this y value. Okay. So what I'll write here, y equal to x minus 2. The value of y is 2 lesser than x. Here, what about x? X we can take it as 5, or x we can take it as 6, x we can take it as 7. All these things I am writing by using this arrow diagram. Okay. So I written this relation in set builder form. So first bit is over. By seeing this arrow diagram, they are asking you to write this in roster form. What is roster form? In roster method, all the elements are listed and separated by commas within the brackets. You observe here, 5 is related to 3. By seeing this figure, we can easily write this is order pair 5, 3. And second one is ordered pair 6, 4. And third one is order pair 7, 5. In this, how many elements are there in this relation? 3 elements are there. Okay. So I written this relation in roster form. Writing it into roster form is very easy. Now, second bit is completed. Now, you see this third bit, domain and range. Domain of relation. What is the definition of domain of the relation? The set of all first elements of order pairs in the relation. the set of all first elements of ordered pairs in the relation. You observe these are the first elements of ordered pairs in this relation. So what are first element? 5, 6, 7. These are all set of all first elements of ordered pairs in this relation. So domain is 5, 6, 7. And one more thing they are asking, what is that? Range. Range of this relation. Okay. What is range? The definition of range is the set of all second elements of ordered pairs in the relation. You observe here, what are the second elements? 3, 4, 5. They are the second elements of ordered pairs in this relation. So the range is 3, 4, 5. I hope you understand this. You observe what is the given information. They given set A equal to 1, 2, 3, 4, 6. You observe 5 is not given here. By mistake you may write 5. First I'll write the given information. Set A given as 1, 2, 3, 4, 6. In the process of doing this problem, I need A cross A. So here I'll calculate A cross A. You know how to calculate A cross A. You see, you imagine one more A here. 1, 2, 3, 4, 6. A cross A means you take an element 1 and you pair with all the elements of this A again. A cross A. A cross A means set of all ordered pairs. We learned this in first exercise. Ordered pair 1, 1. Ordered pair 1, 2. Ordered pair 1, 3. Ordered pair 1, 4. Ordered pair 1, 6. Now you take the element 2 and pair with all the elements of this set. Then you will get, now you take the element 3 and pair with all the elements of this set. Like that you calculate A cross A. You observe here I written A cross A, but actually you no need to write A cross A. But if you know what is A cross A, then we can do this problem very easily. They given set A and I written A cross A. And they are saying that R is a relation on A. R is a relation on A means what? R is a relation from A to A. And the relation R is defined like this. The relation R is defined as set of all order pair A comma B. A and B both are there in set A. And they given that B is exactly divisible by A. This B is exactly divisible by A. Now you observe what they are asking in first bit. Write R in roster form. We need to write this relation in roster form. Now you need to find an order pair A comma B such that B is exactly divisible by A. All these order pairs we will get from A cross A. You see this order pair. You see this order pair 1, 1. This is like A comma B. You observe here 1 is exactly divisible by 1. Look here, 1 is exactly divisible by 1. Yes, 100%. 1 is exactly divisible by 1. So that means the order pair 1, 1 belongs to this relation. Now you see this order pair 1, 2. This is like A comma B. What they are saying here, B is exactly divisible by A. That means 2 is here in this order pair. 2 is exactly divisible by 1. See, yes, 2 is exactly divisible by 1. Yes, 1 how many times? 2 times. So you will get 0. As you are getting remainder 0, we say that it is exactly divisible. So the ordered pair 1, 2 is in the relation. Order pair 1, 3, you just observe that 3 is exactly divisible by 1 or not. 3 is exactly divisible by 1 or not? Yes, 3 is exactly divisible by 1. So order pair 1, 3 belongs to this relation. Similarly, the order pair 1, 4 also belongs to this relation. The order pair 1, 6 is exactly divisible by 1? Yes, 1, 6. Now, I checked till here. Now you see this one, order pair 2, 1. This one, order pair 2, 1. Here this is like A comma B. Here 1 is exactly divisible by 2. B is exactly divisible by A means 1 is exactly divisible by 2. Check that 1 is exactly divisible by 2. No. 2 is exactly divisible by 1. But 1 is not exactly divisible by 2. So here this order pair 2, 1 belongs to this relation or not? No. The order pair 2, 1 does not belong to this relation. Now you check this order pair 2, 2. Order pair 2, 2. That means here B is exactly divisible by A. 2 is exactly divisible by 2. Yes, 2 is exactly divisible by 2. That's why the order pair 2 comma 2 comes to this relation. Is 3 is exactly divisible by 2? No. That's why we won't take this. Is 4 is exactly divisible by 2? See here, 4 is exactly divisible by 2. Yes, 4 is exactly divisible by 2. 2 times, remainder will get 0. So the order pair 2 comma 4 comes to this relation. You see this is also I checked. Now you see the order pair 2 comma 6. Is 6 is exactly divisible by 2? Yes, we know all these things. 6 is exactly divisible by 2. You check here, is 1 is exactly divisible by 3? 1 is exactly divisible by 3. Check here. No, this we won't consider. Okay. 2 is exactly divisible by 3? No, we won't consider. You see the order pair 3 comma 3. 3 is exactly divisible by 3? Yes. So the order pair 3 comma 3 will be in this relation. Is 4 is exactly divisible by 3? No. Is 6 is exactly divisible by 3? Yes. So the order pair 3 comma 6 belongs to this relation. And you check, is 1 is exactly divisible by 4? 1 is exactly divisible by 4? No. So this order pair won't comes in this relation. Is 2 is exactly divisible by 4? You observe here, B is exactly divisible by A. Is 2 is exactly divisible by 4? No, this also won't comes in this relation. 3 is exactly divisible by 4? No. 4 is exactly divisible by 4? Yes. So the order pair 4 comma 4 comes in this relation. Next, is 6 is exactly divisible by 4? No. Is 1 is exactly divisible by 6? No. Is 2 is exactly divisible by 6? No. Is 3 is exactly divisible by 6? No. Is 4 is exactly divisible by 6? No. Is 6 is exactly divisible by 6? Yes, 6 is exactly divisible by 6. Now we completed first bit in this question, write R in roster form. Now what they are asking, find domain of the relation. Second bit is find domain of the relation. You know what is domain. What is the definition of domain? Domain is set of all first elements of ordered pairs in the relation. The set of all first elements of ordered pairs in the relation. You see in this relation, all first elements, the set of all first elements, here everywhere 1 is there. So I'll write 1, next 2 is there. So I'll write 2, and I'm checking what are the first elements of order pairs in this relation. 3 and 4 and 6 is also there. So I verified all first elements of order pairs in this relation. I got 1, 2, 3, 4, 6. So this is the domain of the relation. So second bit also over. Third bit, what they are asking, find range of the relation. What is the definition of range of a relation? Range of relation. In the relation, the set of all second elements of order pairs. Second element, see what second element is there here? 1, 2, 3, 4, 6. Okay, 2 already written, 4 already written, 6 already written, 3 already written, 6 already written, 4 already written, 6 already written. I hope you understand solution for this question. This is sixth problem in exercise number 2.2. Chapter name is Relations and Functions of class 11. You observe what they are asking in the question. They are asking domain and range of a relation, and the relation is defined like this. First, I written what is the given relation. To write domain and range of this relation, I'll write this relation in roster form so that I can easily write domain and range of this relation. Here, what are the x values I can take? In the question only they given x, you can take 0, 1, 2, 3, 4, 5. You can take these are all as x values. So I'll write this relation in roster form first. In place of x, you write 0 in this. Okay, 0 comma 0 plus 5. 0 plus 5 is 5 only. So you will get the first order pair in this relation. This relation is in set builder form. I am writing this relation in roster form. Okay. Now, in place of x, you write 1. In place of x, if we write 1, 1 plus 5 is 6. So, the second ordered pair is 1, 6. In place of x, you take 2. You substitute 2 here, 2 plus 5. 2 plus 5 is 7. Now, in place of x, you write 3. Okay. So, what you will get here? 3 plus 5. 3 plus 5 is 8. In place of x, we can take 4. If we take 4, 4 plus 5 is 9. Okay. In place of x, you write 5. 5 plus 5 is 10. Okay, you written this relation in roster form. Once we written the relation in roster form, it is very easy to write domain and range of that relation. Domain of relation. What is the definition of domain of relation? The set of all first elements of order pairs. You observe, this is first element of order pair. These are all first elements of ordered pairs. The set of all first elements of order pairs in the relation is called domain of the relation. So 0, 1, 2, 3, 4, 5. These are all the first elements of order pairs in this relation. So domain of this relation is this one. Now I'll write range of the relation. Range of the relation R. Okay, what is range definition? The set of all second elements of order pairs. You observe what are the second elements? 5, 6, 7, 8, 9, 10. These are the second elements of order pairs. So I'll write those things. 5, 6, 7, 8, 9, 10. So these are all the second elements of order pairs in this relation. So I calculated domain of the relation and range of the relation. I hope you understand this class. You observe here what they are asking in the question. Write the relation. This relation is in set builder form. X comma x cube such that x is a prime number less than 10. In roster form. We need to write this relation in roster form. This is the given relation. Given R equal to order pair x comma x cube such that x is a prime number less than 10. Here this is important. What we can take x value? X is a prime number less than 10. That means you can take x as 2 because 2 is the least prime number which is less than 10. And 3 is a prime number. Next 5 is a prime number. Next 7 is a prime number. Next 11. But 11 is not less than 10. These are the prime numbers which are less than 10. Now they are asking to write this relation in roster form. So R equal to, in place of x you take 2. What you will get? 2 comma 2 cube. Okay. Next in place of x you take 3. What you will get? 3 comma 3 cube. Next in place of x you write 5. 5 comma 5 cube. Next 7. 7 comma 7 cube. I hope you are understanding. Right? So we written this relation in roster form. However, little bit of simplification is possible. That step also I'll write. R equal to 2 comma 2 cube is 8. 3 comma 3 cube is 27. 5 comma 5 cube is 125. Okay. 7 comma 7 cube is 343. Now we will, you see question number 8. Set A is given. Set B is given. They are asking find number of relations from A to B. Number of relations from A to B. Here, how many elements are there in set A? Number of elements in set A. Here, 3 elements are there in set A. That means number of elements in set A is 3. And how many elements are there in set B? In set B, 2 elements are there. And we know that if set A has 3 elements, set B has 2 elements, number of elements in A cross B. In A cross B, how many elements are there? 3 into 2, 6. This we learn in Cartesian product of sets. Set A has m elements, set B has n elements, then number of relations from A to B equal to 2 power number of elements in A cross B. This is the formula we learn while learning the definition of relation. Therefore, number of relations from A to B equal to 2 power n of A cross B. Here you see what is number of elements in A cross B. We got 6 elements. So in place of n of A cross B, we will write 6. What is 2 power 6? 2 power 6 value is 64. 64 relations we can form from set A to set B. It is important. You need to remember this formula to do this problem. Number of relations from A to B formula 2 power number of elements in A cross B. You see this 9th question what they are asking. They are given that R is a relation on Z. That means R is a relation from Z to Z. And the relation defined as order pair A comma B such that A, B both are integers and A minus B is an integer. Then find domain and range of the relation. First, I'll write the given relation. This is the given relation. This relation contains ordered pair A comma B. A, B both are integers and A minus B is an integer. Here, one point you need to understand. For any two integers a comma b, if I take a comma b as any two integers, a minus b is always an integer. You can check this with an example. When you take a and b are two integers, a minus b is always integer. A minus b is always an integer. For any two integers a comma b, a minus b is always integer. You observe, you take any two integers. For example, 3 I will take, 5 I will take. 3 minus 5 is what? 3 minus 5 is minus 2. Minus 2 is an integer. Like that, you take any two integers and subtract, again you will get an integer. If I calculate z cross z, you see first one, what you will get? First 0 comma 0. 0 minus 0 is 0. It is an integer? Yes. Now you take 0 comma plus 1 you take here. 0 comma 1. 0 minus 1 minus 1. Minus 1 is an integer. Next 0 comma 2. 0 comma 2. 0 minus 2 is what? Minus 2. Minus 2 is an integer? Yes. So what happens? 0 comma 3. It continuously will get, it's an infinite set. What I am trying to say here, domain. What is domain? Set of all first elements of order pairs in the relation. But if we cannot write this relation is in infinite set. This relation is an infinite set. But we can observe here with 0. Here 0 is then next plus 1 minus 1, like that. What you will get? Domain is an integer. You need to understand this. Domain of this relation is an integer. Next, what is range? They are asking range. Range is also an integer, because range definition is what? Set of all second elements. You can observe here 0, 1, 2, 3 is there. Like that, minus 1, minus 2, minus 3 also we will get. What point I am trying to say? This is the main point. See, for any two integers a comma b, a minus b is always integer. So for this relation, domain is set of all integers. Range is also set of all integers. I hope you understand this solution.